Alright, hey everyone. So I'm a little bit late this week with the video. That's really just been because of studying and all that sort of stuff for the midterm. I haven't got heaps of stuff done this week on the rootkit. I looked at, again, privilege escalation and using that to explore how we can implement our own system calls to sort of extend the kernel in different ways. And then I also looked at file hiding and reboot persistence. So file hiding, there's still a little bit more work to go with it, as I'll show you, but it's good enough at the moment that we can hide the presence of the fact that we can persist through reboots with our rootkits. So that's pretty cool. So the first thing I'll show you is going to be like an example of this rootkit escalation, and it's pretty neat if we open this up with htop on the left while we do this. So if I make this rootkit and then, load it into the kernel like we usually do, I can then use this Perl script to change the owner of any process on the system. So we can see here at the moment we got like 2241's currently owned by me. But if we do demo.pl and then 2241, you'll see that it switches through to root, and any process that's owned by it or is a child of it will be updated too. So now if we do who am I, you can see that my shell is set to root. So that's pretty awesome. It means that we can, basically before we could write to a character device and that would take the calling process and upgrade it to root, we can now do that for any process. And then what might be cool here is to extend this a little bit and then hide the process as well. So we've got a root process that is then hidden from things like htop or anything like that. So that's pretty cool. The second one is this file persistence or file hiding. So this one's a little bit more complicated. We'll go through the code to both of them actually. Maybe let's take a look at the escalation one first, as that's a little bit easier. So this is pretty similar to the other rootkits we've seen in that it's a kernel module. We again have to include a lot of header files up the top. Here we have to specify the arguments of our system call, because if you remember, every system call on BSD comes in this format. Every system call comes in this format. We have a pointer to the thread that called the system call, and then we have a void pointer as the args, and then we have to cast that to the correct struct. So here we set up and we just say we want a PID. That's basically it. We then do one of these guys. We basically loop through every single process in the system. We use PID hash, that makes it a little bit faster. And then if the PID matches the one that the user specified, we then just update all of its credentials. So we give it an actual and a saved UID of 0, which is root. The rest of this is pretty straightforward. We need a sysentry to tell the kernel what this is. So here we say we've got one argument, which is the PID, and then we also have a privsec, which is just a pointer to the function above. All of this load stuff is pretty standard. We don't do anything when we're unloading, and loading into the system is we just give it the offset. So we could see there it was system call number 210, and that was what we needed to call. And then down here is just again a macro to handle all of the registration. So it's pretty straightforward. The next thing that's worth looking at is how FreeBSD, or I think BSD in general, loads stuff in. And hopefully there's a man page for this. Yeah, so this is the RC utility. And basically there's a directory which has all these scripts in it. And then at boot, it will call each of those scripts. So we have one that is called something like hide module. Or maybe file module? Yeah, file module. And you can see this at the moment because we haven't loaded the rootkit in. So I wouldn't really worry too much about understanding how this bit works. It's not really relevant to how the rootkit works, I guess, and it's pretty specific to FreeBSD. You know, Windows and Linux have quite different ways of loading stuff in. So this is basically just some shell scripting, and there's a pretty cool walkthrough on FreeBSD's website about how to set this stuff up. I just followed that. And so whenever we call hide module start, which will happen automatically for us at boot, is that it will go and run the code in this function. So it'll just do KLD load hide.ko. And once this is running, it will then hide the existence of this script. So you won't be able to see it on the system, if that makes sense. Because it will, if you ls it or do anything like that, you're going to call the getDirEntry system call. And in this rootkit, we have hooked that system call and we filter the results out. So we'll take a look at how that works, and then I'll give you a demonstration. Okay, so here is how it works. Again, we've got a buttload of includes. I wouldn't worry again about those too much. Here we call, we do the same thing we do for every other hooking system call that we've done. We set up a size, an account, and then a pointer to DP and a pointer to current. We then call the sysgetDirEntries, and if you know about Unix system calls, the return value of like what sysgetDirEntries will return is like an error, and then the return value for the actual system call that the consuming process is going to receive is actually in td retval 0. So this will be the size. Yeah, if you check the man pages, the return type is the actual size of the directory. So there's a little bit of extra work we need to do for that. So we get the size, and if the size is equal to 0, it means we've got an empty directory, right? So we can just return because we don't care. There's no files hiding, or there's no files that we want to hide in an empty directory because it's empty. We malloc a space that's the size of the object we're returning from the system call that we just made. And then we malloc because this could be quite big and the kernel stack is quite small. So we malloc it into just the heap area, I guess. We then copy in the contents from buffer into the area we just malloced, and this is because this will be, a user buffer somewhere in user space that will segfault if you try to access it. So we set our current to equal the start of DP and our count to equal the size. We then decrement the size and we keep looping around. So we go through every entry. For each entry, we do a string comparison and see if the name of the file matches file_module, which is that startup script that we're trying to hide. If it does, we then want to copy everything after that into its current space. So we reduce the size that we're going to return, because it looks a little bit suspicious if the size doesn't match up with the contents of the directory that we're claiming to be returning. So we then copy it across into that new area to sort of overwrite the file module entry, and then we decrease the size. If the count isn't 0, we then move along to the next entry and we repeat the process. We then set the return val to match the new size. Maybe we've had to decrease it in size if we found a file that we want to remove. And then we copy the changes we've made back to that buffer, and then we free the space in the kernel. And that's about it. Here I've been a little bit nice, and if your machine was infected, you can still unload this rootkit. We want to change that in the future. And then we just have the usual declare module and all that sort of stuff. Okay, so instead of loading this in and showing you what it looks like, I'm actually going to go through the boot process. So we're going to turn the machine off, let it load in, and I'll show you that it's running through KLDstat, and then we'll see if we can find that file module in etc.rd. And if it's all gone right, that should be no longer visible. So let's take a look at that now. So I'm going to log out of PuTTY, and then we're going to come over to our virtual machine over here, and then we're going to turn it off. I'm going to shut it down. And now we're going to hit reboot, and we'll go through the actual boot process. We're going to boot into multi-user like we always do. All right, cool. So I'm now going to SSH back into this, and I'll set it up so you can view it more easily. Change it to like a nice big font, and we'll go full screen. So if we now do sudo KLDstat, and I put in my password, you'll see that hide.ko automatically exists. So we're going to look at, again, how we can modify the results of KLDstat to hide the kernel modules that we don't want it to see, or for users to see. And now if we come to the location of that, if I do a grep now for file, you'll see it's not there. But I don't get autocomplete or anything like that, but I can still open it up. So it does exist on the system. It's just that our hooks worked and hidden it. One of the problems I've noticed with this that I've been looking at, I know how to fix it, I just haven't had time to, is if I come to another folder, say just this one, if I try to make a file with the same name, call it file module, see it's written, but if I do a grep for it, it's still missing. So what we're going to want to do, and I'll do this week, is we're going to actually want to call fstat@, and we're going to want to check if there's if like the file we're looking for is in the correct directory as well. Because if it's in a different directory, if users accidentally make a file with the same name at the moment, and then they can't see it, they're going to know something's up. Then they're going to reinstall their operating system or figure out there's a rootkit installed. So we're going to want to change that. That's pretty much it. That's all I've got for this week. So we've got reboot persistence here, so we can turn the machine on and off and the rootkit will stay alive. At the moment, I've still made it pretty easy to disable, and that's just because while I'm developing it, I don't want to infect my own machine, so make it pretty easy to get out. We've also got privilege escalation, and we did that by implementing a new system call, so that was pretty sweet. So again, I'm going to be focusing more on how to hide stuff now, how to hide entries in KLD stat, how to hide processes, and all of that sort of stuff. The other thing we also want to be looking at is, can we do some stuff so that it's not so obvious that we've changed the system entry table? So I've been reading up different ways to avoid that sort of stuff. But yeah, that's pretty much it. Thanks for watching and listening.